Hi Math 2 friends. Let's get this radical checkup taken care of so that you can know what you need to fix by the time exams come around. So this first one is just really helping you illustrate a property of radicals. It states that if two radicals are multiplying, then the radicands can multiply and be rewritten as one radical if and only if the radical or the root is the same. So remember, both of these have an understood 2 here, right? So that since that's the same, we're able to rewrite it as a single radical. Another illustration of that would be x to the half times y to the half. That's the same as xy to the half. Okay? The second one, we're able to do one of two things. We can either simplify it inside and then get 10, or we can split it up, and this is probably the more useful property, do them separately, and they should both turn out to be the same. 20 divided by 2, yep, that's 10. Okay, square root of 64 is just 8, right? A number that multiplies itself to get 64. So you could think of 64 as 8 times 8 and go through that whole, the square dance. And hey, there's a pair, they're gonna go out and square dance. Or the twin story, where you spot a twins, one kills the other and goes outside. That's kind of violent. It's really just helpful to understand that 8 times 8 is 64. Thus, the square root of 64 is 8. 80, so we want to think about the factors of 80. So you could do 2 and 40, you could do 5 and 16, you could do 4 and 20. We'll do 4 and 20, even though 5 and 16 is going to be our best choice. We'll break it up into 4 and 20, and we'll think, well, the square root of 4 is 2, and then the 20, well, I'm not done yet. The 20 can be split up into 4 and 5, and the square root of the 4 is another 2, so I have 2 times 2. The 5 cannot come outside. I didn't take the square root, so it's still square root of 5. So we end up with the 4 times the square root of 5. Now you're seeing, hey, if a 4 was able to come out, that means there must have been a 16 in there. So we could have done this 16 and 5. The square root of 16 is where that 4 comes from. Right? Oops, that's supposed to be a 5, wasn't it? All right, so 4 times the square root of 5. These last ones really illustrate a couple of things. The 3 and the 5 are both outside, so they're going to operate just like coefficients. 3 times 5, yep, that's 15. And then the 6 and the 3, those are inside, so that's going to be 18. But we can't stop here because 18 can be broken down into a perfect square if we see that as 9 and 2, and the square root of 9 is 3, so I have 15 times 3 times the square root of 2, or 45 square root of 2. All right, these next ones, we didn't do too many of these, but they're going to operate on the same principle. So we can take the square root of 16, it's 4. We can take the square root of x squared, it's x. And the square root of y to the 4th is y to the 2nd. Again, if you expand all this out, this should all be evident, like so, right? Because we're able to see those pairs. 4 times 4 is 16, thus the square root of 16 is just 4. We're going to take that into consideration here with 32 and use 16 and 2, x squared and x, y to the 4th and y. We're going to take the square root of the 16 and get 4, the square root of the x squared and get x, the square root of the y to the 4th and get y squared. Now what do we leave inside? The 2xy. Okay, now we're going to do our first cube root, so that's really what can I raise to the 3rd power to get 48, to get x to the 8th, to get y to the 10th. So they're going to have to be split up, and you might not know this, but 8 is going to be the cubic factor, the cubic multiple, I should say, of 2. We're going to change that x to the 8th, split it up into x6 and x squared. We're going to change the 10, the y to the 10th to y to the 9th and y. Now, the variables work a little bit differently. We're just looking for an exponent that is divisible by the root 3. So x to the 6th and y to the 9th fit that description. The cube root of 8 is 2. The cube root of x to the 6th is x to the 2nd. It's kind of like just dividing by the root, remember? And then the cube root of y to the 9th would be y to the 3rd. Now what's left over? The 6, the x squared, and the y. All right, another illustration of the property from number 5. 2 and 5 are both outside, so they can multiply. They behave just like coefficients. And then we have a 5, a 2, and a 10. So we're going to have times the square root of, I believe that's going to be 100. That's just a 10, so we have 10 times 10, or 100. And our last one, 2 and 4x become 8x, 3x, and 6x cubed are going to become 18x to the 4th. Now we can actually take the square root of x to the 4th and get an x squared. And you know that we can split 18 up into 9 and 2. So we're going to take that square root of 9 and get 3, and the 2's got to stay inside. So my final answer here is going to be 24x to the 3rd times the square root of 2.